Hello. Today we discover how machines learn from data. Imagine wanting to predict a house price. You'd consider its size, bedrooms, and location. Machine learning works similarly. It's where computers learn from data to make predictions or decisions without explicit programming. We provide many examples, and the computer figures out the patterns itself. This allows machines to tackle complex problems like image recognition or predicting stock prices by learning from observed data. To learn, machines need data. Data is simply a collection of information, often structured like a spreadsheet. For our house example, each row represents a house. Columns like size or bedrooms are features. Features are the specific, measurable properties a model uses. The more relevant and well-structured our features, the better our model can learn and predict for new houses. Once we have data and features, we build models. A machine learning model is a mathematical representation, finding relationships between input features and the output we want to predict, like house price. Think of it as a function. Feed it features, it outputs a predicted price. Initially, predictions might be poor. The goal is to adjust this model until its predictions are as close as possible to true values. How do we know if our model makes good or bad predictions? We need a loss function. This quantifies the error between the model's predicted value and the actual true value. For example, if the model predicts $300,000, but the actual price was $350,000, the loss function calculates how wrong that prediction was. Higher loss means worse performance. Our goal is to minimize this loss. One common loss function is the mean squared error, or MSE. For each data point, it calculates the difference between predicted and true value, then squares this difference. Squaring prevents errors from canceling and penalizes larger errors more. Finally, it averages all these squared differences. This gives a single number representing the model's overall error. Our goal is to find model parameters that result in the smallest possible mean squared error. Knowing how to measure error, how do we improve our model? This is optimization, and a key algorithm is gradient descent. Imagine the loss function as a mountainous landscape. Our goal is to find the lowest point, where error is minimal. Gradient descent repeatedly takes small steps in the direction of the steepest downward slope. This process guides our model's parameters towards minimizing loss, making predictions more accurate. When using gradient descent, the size of each step down the loss landscape is controlled by the learning rate. A large learning rate means big steps, which might be faster, but risk overshooting or bouncing erratically. A small learning rate means tiny steps, safer and more precise, but the learning can be very slow. Finding the right learning rate is critical. It balances speed and precision to efficiently reach the optimal model. After training, how do we know if our model performs well on new data? We split our data into a training set and a testing set. The training set teaches the model, adjusting its parameters. Once training is complete, we evaluate the model on the testing set, which it has never seen. This provides an unbiased estimate of how well our model generalizes to real-world data, preventing memorization of training examples. When a model learns, two problems can arise: underfitting and overfitting. Underfitting occurs when a model is too simple, failing to capture underlying patterns. It performs poorly on both training and testing data. Overfitting happens when a model learns the training data too well, memorizing noise rather than general patterns. Such a model performs excellently on the training set, but poorly on new data. The goal is a model complex enough for true patterns, but simple enough to generalize well. To recap, machine learning involves a continuous loop. First, we prepare data with its features. Then, we design models for predictions. We measure prediction quality using a loss function. To improve, optimization algorithms like gradient descent, guided by a learning rate, minimize the loss. Finally, we evaluate the trained model on unseen testing data to ensure it generalizes well. This iterative process allows machines to learn and make intelligent decisions. Thank you for watching. Please like and subscribe for more.